Hello, I'm solving this physics paper 5 variant today. This is February March 2022, 9702 variant 52. So paper 5 is 30 marks. So divided into two sections, part 1 and part 2. Part 1 is planning. The second part is analysis, right? Analysis and evaluation. So let's start with number 1. We have a trolley with a magnet attached. It is placed on a thin steel sheet as shown in figure 1.1. The angle between the sheet and the bench is theta. The distance from point X to the trolley is d. The trolley is released from rest and travels down the slope. The velocity v of the trolley at x is determined using a light gauge. It is suggested that v is related to theta by the relationship mp sin theta minus qb is equal to mv squared by 2d, where m is the mass of the trolley and magnet b is the magnetic flux density. Mass of the trolley and magnet, b is the magnetic flux density between the magnet and the steel sheet, and P and Q are constants. Plan a laboratory experiment to test the relationship between V and theta. Draw a diagram to show the arrangement of your equipment. Explain how the results could be used to determine values for P and Q. In your plan, you should include these. Okay, so I'm just going to break it down. I'm going to break the marking scheme. So there are 2 marks for defining the problem. What does this actually include? There are 2 marks for defining the problem. Wait, yeah. This is basically stating what the independent and dependent variables are and what the control variable is. Something that has to be kept constant for each experiment, something that we need to standardize. Okay. Now, there are 4 marks for methods of data collection. There are 4 marks for this. These mainly deal with like 1 mark from here, from methods of data collection, is actually the diagram. So if you draw a proper diagram, you're going to score 1 mark here. And the other 3 marks are typically how you're going to measure or calculate the independent and dependent variables. Okay, and usually there's 1 more mark for giving some extra information about how you're going to carry out this experiment to reduce errors. Okay, so what about the other marks? We got 6 from here. So there are 3 marks for analysis, right, for the method of analysis. There are 3 marks for this. This is mainly how you're going to confirm the relationship, right? So what you need to draw, right, when you plot a graph, right, if you want to test the relationship between 2 things, you need to plot a graph between those 2 variables and see if a straight line is produced or not, see if it's a curve or something. If it's a straight line, right, that means that the relationship is valid, and sometimes the straight line will pass through the origin, sometimes it won't, so you need to mention that, right? So there are 3 marks for this, and within this part is included. Like sometimes they'll ask you, yeah, like here, explain how the results could be used to determine values for P and Q. This is part of methods of analysis. You need to mention that over here. All right, what about the other 6 marks? So for methods of analysis, these 9 marks that I've given here, the points are fixed. You cannot deviate, you cannot get marks for any other points, but there are some additional details including safety considerations. There are always 10 marking for points for these safety considerations. Okay, and the additional details, you can score 6 out of 10 from here. But if you write down 10 points from here, you aren't going to get the extra marks. You're going to get capped out at 6. Okay, so there's room for error, but you can max out at 6 from additional details. Okay, so additional details, plus safety. It's actually 6 marks, even though there are 10 points. Okay, you can only get um, 6 at max. Okay, moving on. So personally, I prefer doing the analysis first and defining the problem. This is how I approach the sum. So clearly, I know that there's a relationship between v and theta. So one of them is independent, and the other is the dependent one. Okay, so just think about it. You're gonna think of it this way: what are you going to select in the first place, right? Like, are you gonna find out velocity in the first place or set the angle? Just think about it. Clearly, we're gonna set the angle first, right? We're gonna set this theta first, then let the trolley go, right? Then it's gonna fall down the slope. Then we're gonna find out the speed. So clearly, speed is coming after the angle. What does that mean? This means that theta, right? Theta is actually the independent variable, and v is the dependent variable. So that's our first mark. Theta is the independent variable, and v is the dependent variable. You could also go for, like, an alternate way of saying this is vary theta and measure v. It's the same thing. So what about the variable that needs to be kept constant? So there might be multiple things that need to be kept constant, but you need to look for the most important point over here, right? So typically it's hidden within the equation. Okay, so uh, it's not going to be sine theta or v square, right? Since it's part of the equation, so it's not going to be those. Also, it's not going to be p or q, because we need to explain how we're going to determine them. So we're not going it's not going to be p and q. What about the other ones? What do we have remaining? We have mass, right? We have mass, we have magnetic flux density, and we have the distance from which the trolley is going to be released every time. So out of these three, anyone could be the, any one of these could be the control variable. You had no idea of knowing. So personally, if I was giving the exam, I'd just write down keep b, m, and d constant, or keep m constant, keep b constant, keep d constant. For a fact, I know that it's going to be one of them. Typically, it is. So I had no way of knowing it, right? And you don't have to say that d is the control variable or something. You just have to say that keep d constant. So it doesn't have to be at the beginning either, right? It can be anywhere in your question. You're gonna get full marks for that. It's totally fine. So, like, I know the mark scheme, right? So it's gonna be like, it is actually d. So this was the first one, right? This is the second one. We should keep d constant, right? And if you even wrote down this other point, right? I'm gonna use red for that. If you wrote keep b and m constant, it's fine. You're gonna get 1 mark for this. This mark is from additional details. Okay, so if you actually rearrange them, if you wrote keep b and m constant and then wrote about d, it's fine as well. You're gonna get marks for that as well. Okay, so it doesn't have to be the control variable first followed by the additional detail. It can be arranged either way. Okay, so yeah, that's it for defining the problem. Now let's talk about methods of data collection, and mainly the diagram. Okay, so what about the diagram? So typically you just have to look for what's missing. So I'm just going to copy the diagram as it is. This was the diagram. We had the ground over here, then followed by the steel sheet, right? This is our steel sheet. So clearly it's looking like the steel sheet is levitating, right? So what's missing? A support, right? So we just need to make sure that a stand or a support is given. Stand or support, right? We are also going to label the steel sheet. Okay, then we're going to label point x. We're going to label point x, and we're going to label the trolley as well. Okay, so this is fine. This looks okay, and this is distance d. Um, so they also mentioned about light gates, right? They also mentioned about light gates at d. We're using that to find out the velocity. So we can draw the light gates actually. You can draw some light gates here. Okay. This is actually on the sheet, right? Like, actually not on it. It's either behind or in front of it. So when the trolley passes in front of it, it's gonna give us a reading. Okay, so we need to show two actually, because we need two time readings so that we can actually find out the time difference between those readings, right? And we know the distance between them, right? So we can find out velocity. V is equal to distance by time. So this is actually the counter, right? Or this is what will give us the reading. So this is our light gate, or our light gates. You can label both. So you need to label the stand and light gate. So anything you add to the diagram, you need to label it. Okay, remember that. So this is our bench. Hopefully that's clear. So this is one mark from methods of data collection. Now we're going to talk about how we're going to calculate theta, or measure theta and calculate v. Okay, so this is actually not called the timer. You can call it the uh, it's not called a counter, my bad. It's called a timer or data logger. Okay, this is called a timer or data logger. So you can get a mark for this. If you draw it on the diagram, you can write it down as well, so it's fine. So now we're going to talk about the methods of data collection. You don't need to give headings. Okay, so I'm just going to talk about the methods of data collection. Now I get 1 mark for the diagram. Now I'm going to say that um, the light gate the light gates are connected to timers or data loggers, right? Next, how do we find out velocity actually? So basically there is a distance between these light gates, right? Clearly. So the front of the trolley is gonna pass it twice. Pass the front, and light can no longer pass through the gates. That's when we're gonna get a reading. When the uh, when the field of view will be hampered, right? We're gonna get a reading. So this is how we write it down actually. We can say that we can measure the length interrupted by beam for a single light gate. Okay, and what's this final point? We can measure theta using a protractor. So these are these green lines, right? These are points for methods of data collection along with the diagram. We get 4 marks from here, but I want to write about some additional details over here. Okay, clearly we did not give enough info about calculating velocity. So how are we going to do that? Okay, so mainly we can write this: determine v, the velocity at x, basically by using L divided by T for a single light gate. Okay, so you don't actually have to use two. You can use a single light gate. That's also fine. Okay, because just think about it. If you want to use a single one, you can use two if you want, but there is an option to use a single one. How exactly? Mainly, you can just keep it at point x over here, right? You can keep it at point x. So the trolley is actually gonna, the front of the trolley is gonna pass it once, right? And then the part at the back will pass it again. So light will be interrupted, right, for some time, right? So we can use that information to calculate the distance and calculate the velocity, I mean. Because we can actually find out the distance beforehand, right? Even before the start of the experiment. How? We can measure the length interrupted by the beam for a single light gate. Okay, so they're basically talking about this distance over here, right? So we can think about that. Using a card, we can do that using a card. We don't have to use the trolley. So just think about it. What's going to happen when the trolley passes the light gate? So initially when it's going to be here, when the trolley is going to be here, light will be interrupted, right? And when it's going to leave again, it's going to be like this. It's going to pass the light gate and we're going to get a reading after it passes. So we can actually find out the length using a card that has been interrupted, right? And we're going to get the reading as well, right? How long light was interrupted for, right? So using that information, we can find out velocity. So what length are they talking about? It's actually the length of the trolley, right? They're talking about this length, the pink one I drew. So how to determine V? Determine V using L by T for a single light gate. That's enough. You could also opt for 2, but this is fine. Since this is the most recent maximum, they're opting for 1. You can also give some additional details about measuring theta, right? Like what? You can actually draw a protractor in the correct position on the diagram. Okay. Or just think about it. You're going to look at your relationship, right? You have sine theta. So we know that sine theta is equal to opposite by hypotenuse, right? So you can actually use that relation. So you can give a detail about this, how to measure sine theta. You could say that sine theta is equal to, you can measure some lengths over here. Like you could go for this. You could call this opposite, right? And you could call this length hypotenuse, right? You could just go for sine theta is equal to opposite by hypotenuse. That works. Or you could just opt for the drawing of the protector properly on the diagram, right? So it's gonna be something like this. You could draw it over here, right? And you could label this as the protractor. That also works. Okay, so this is an additional detail for measuring the angle. Okay. I'm just erasing it for now, or else it's going to be a bit too messy. So let's write down the other additional details now, the ones that are remaining. I wrote 3 already. Okay. So you need to see if we've missed measuring anything. We haven't measured the mass, right? We haven't measured the mass of the trolley and magnet, and we also haven't measured D. So how do we do those? These are the additional details. So use a ruler. Use a ruler to measure D, right? And use a balance to measure mass of trolley and magnet. Okay. What about magnetic field flux density? How do you measure that? So we need to say that we need to measure B using a calibrated Hall probe. Really important. This is essential. we measure the Hall voltage, right, and then we match it with a known magnetic field. That's why it's calibrated. So there was actually 1 mark for both of these points. Okay, 1 mark for both of these. Now we can give additional details about measuring B, right? So what can we say? We can adjust the probe until maximum value is seen, right? Because when will maximum value be seen? When the probe is perpendicular to the magnetic field. Or you could do the other thing, like you could measure Hall voltage twice. First in one direction, then in the opposite direction, and then you could average. That also works. This is an alternate way of saying it. Measure B using probe in one direction, then in the opposite direction, and average. Typically, guys, there are separate marks for this. Okay, there are typically separate marks for these, but basically we have too many points already. That's why they only allowed you to get one. Okay, so we also need to ensure that D is kept constant, right? How can we do that? We can actually mark a distance D on the sheet, right? Or the starting position of the trolley on the sheet. Like we could mark this point using a marker or something. So let's write that down. Keep D constant by marking distance D on the sheet, or you could just say by marking the position of the position of the trolley, the starting position basically, on the sheet. That's the way. So anything else? Okay, there is one more point. There are two more points. I'm gonna write one at the end with analysis. So what's the safety precaution actually? So it's a moving trolley, right? Anyone could get hurt. The person performed the experiment. If it stops, right? If it keeps on going, anyone could get hurt. So what do we need to do? We need to stop the trolley once it passes X. Okay. So we could actually use a pillow or a cushion, you know, or we could place a block. So place a cushion or block to stop the trolley after it passes X. Okay, that's it. Right, so for safety, we need to place a cushion or block to stop the trolley after it passes X to prevent any injuries. I actually missed another additional detail which is common for almost all experiments. Right, we need to say that we need to repeat the experiment for each value of theta. So repeat the experiment for each value of the independent variable, right, to get an average value of the dependent variable. Okay, and average V. That's the wording almost all the time. Repeat the experiment for each value of independent variable and average the dependent variable. Okay. Okay, so for analysis, what do we need to do? We need to study the relationship that has been given. Okay, so write this down. MP sine theta minus QB is equal to MV square by 2D. So on the y-axis, we typically plot the dependent variable, and on the x-axis, we plot the independent variable. So clearly, we stated that V square was the dependent variable. So let's move it to one side over here. MV square by twice D is equal to MP sine theta minus QB. Now, if you just make V square the subject, what are you going to end up with? V square is equal to MP sine theta divided by M into twice T minus QB into twice T divided by M. That's it. Now we can get rid of M here, and you're ending up with V square is equal to 2PD into sine theta minus 2QDB divided by M. doesn't this look like y is equal to mx plus c? So what do you guys understand? 2pd is actually the gradient, right? 2pd is the gradient, and the one on the right hand side is the intercept. So since it has an intercept, it will not pass through the origin. Remember that, okay? So let's go for the analysis now. Sometimes there's marks for working, like showing the y is equal to mx plus c relationship, but over here it's not given. So you could actually draw it inside the question, right? Or you could just do rough work, it's fine. So this is always the first part. You're gonna get marks for this by saying that plot a graph of v square against sine theta. Or you could just go for plot a graph of v square on the y-axis, right? And sine theta on the x-axis. Same wording, same marks now. So typically there's a mark for this in the analysis part, but in this question, this was an additional detail. You have to say that the relationship is valid if a straight line is produced um, not passing through the origin, that does not pass through the origin, because we do have an intercept. Okay, not passing through the origin, that is all. So remember that they told us how we're going to find out p and q. We need to mention that. Okay, that's part of the analysis marks. So we know that 2pd is equal to gradient, right? So p is equal to gradient divided by twice t. We get 1 mark for this, gradient by twice t. Okay, what about the other one? We know that minus 2qdb by m is equal to y-intercept. So what about q? Q is actually equal to minus y-intercept into m divided by twice db. So q is equal to minus mass into y-intercept divided by twice bd. So that's it. We get full marks for this. And just remember there's room for error, but ideally you should be looking for 12 to 14 marks here if you want to get an A star. Okay, so let's move on to question 2 now. The student investigates a circuit containing a capacitor and a resistor as shown. It's connected to a dual beam oscilloscope. A dual beam oscilloscope is connected across the capacitor of capacitance C and resistor of resistance R. The oscilloscope displays two traces as shown. The student determines the phase difference theta between the two traces. The student repeats the experiment with different resistors. It is suggested that theta and R are related by this equation, where F is the frequency of the alternating current power supply. A graph is plotted of tan theta on the y-axis and 1 by R on the x-axis. Determine expression for gradient. So tan theta is equal to 1 by R into, what else is left? 1 divided by 2 pi fc. Okay, so that is our gradient, 1 divided by 2 pi fc. This is it. Okay, this is our gradient. Values of R and theta are given in the table. Each value of R has percentage uncertainty of 5%. Okay, let's see this. Okay, so each value of R has a percentage uncertainty of 5%. Alright, so we're tasked to find out 1 by R and tan theta. Calculate and record values of 1 by R and tan theta. Include the absolute uncertainties in 1 by R. So this is one of the easiest ones. Okay, this is one of the easiest ones. Give me a second. Yeah, so you need to understand that there's a 10 to the power minus 3 attached to it. Okay, why is this important actually? Think about it. If you calculate 1 by 12, you're getting, if you do 1 by 12, you're getting a value of 0.08333, right? So whatever's whatever's the scaling, right, what power you have on the top, remember that you have to do the opposite if you want to find out the value inside the table. So since it's 10 to the power minus 3, I'm just gonna multiply my answer with 10 to the power plus 3. So into 10 power 3, that is 83.33. So what about the significant figures? I'm going to teach you how many significant figures are justified. Since all of these are two significant figures, we are allowed to use, okay, you can either keep it the same, you are allowed to use two significant figures, or one more than two, which is 3. So I'm going to opt to use two significant figures. I'm going to keep it the same. So my answer is going to be 83. All right. Now think about why is this valid? Because if you want to find out the actual value, what do we need to do? 83 into 10 to the power minus 3, which gives us our actual one, right? Hopefully it makes sense. What about the uncertainty? Since 1 by r depends on r, the uncertainty is just going to be 5% of this into 0.05, right? We are getting a value of 4.17. Okay, 4.17. So let's just go for plus minus 4. Okay, let's do the next one. Okay, so I just want to say something else. You need to maintain consistency. Suppose I chose two CN figures at the top, right? Now I can't switch to 3 in the next one, then go to 2 again. Like if you choose 2, just stick with it. Okay, so 1 divided by 16 into 10 to the power 3, we're getting a value of 62.5, which is rounded off to 63, into 0.05, that's 3.125, so plus minus 3. I will give you a tip, by the way. You can find out the last one initially. Okay, so you can go for 1 divided by 43 into 10 power 3. We're getting 23.2, or 23 plus minus 1.16, or just 1. Why did I do this? Because this gives us our lower bound. All values need to be between 83 and 23. That's the logic. Okay, 1 by 22 into 10 power 3, that's 45, into 0.05 is plus minus 2. 1 by 33 into 10 power 3, that's 30. Plus minus 1.5, which is rounded off to 2. Then 1 by 39 into 10 power 3, that's 25.6, or 26, plus minus into 0.05 is 1.28, or just plus minus 1. Okay, so the values of the uncertainty are like this. It should range from 1 to 4. What about tan theta? Make sure your calculator is set to degrees. Tan 80.8, that is actually, so here we have three significant figures, right? So we can opt to use 3 or 4. Let's go for 3. So this is going to be 6.174, which is rounded up to 6.17. Okay, what about tan 59.3? That's 1.684, 1.68. So the values are going to be between these. Tan 77.5 is 4.51. 1073 is 3.27. 1065.2 is 2.16. 1061.7 is 1.857, right? So if you round it off, it's going to be 1.86. Okay, 1.86. That's it. This is how we do it. Okay, let's move on. We don't need uncertainty for this. Now let's draw the graph. So listen, you cannot use blobs. Blobs are not allowed. Just go for dots or crosses. I personally prefer crosses. Just go for crosses, okay? Trust me, you do that in chemistry as well. So, what's the first point? 83, 6.17. 83, so this is 80, right? 83 and 6.17. So, this is 80, 81, 2, 3. So, what's the scaling like? 6.1, 6.2, 6.3, 6.4, 6.5. So, 81, 2, 3, 6.1, 6.4, 15, 17 should be somewhere over here, right? Start to draw. I'm gonna zoom in. This is 6.17. What about the next one? It's actually 63 and 4.51. 63 and 4.51. 4.51. 61 to 3. So this is the one I marked, right? That's 4.6. Before we did 6.17, which was 6.1, 6.2. In between 6.1 and 6.2. Now we have 4.51. So it's gonna be just a bit higher than 4.5, just a bit higher. So it's 63 and just a bit higher. It should be over here, somewhere here. This is 6.51, okay? What about the next one? 45 and 3.27. 45 and 3.1, 3.2, 3.3, right? 3.1 and 3.2, 3.3. So we're looking for 3.27. 3.25, 3.27 is over here. 3.27. Next. 30 and 2.16. 30 and 2.16. This 2.1, 2.2, 2.16 should be over here. Now 26 and 1.86. 26 and 1.678. 1.86 is over here. Last point, 23 and 1.68. So 23 and 1.68 over here. Okay, that's it. So now before joining the points, we should draw the error bars, right? They want us to draw the error bars. After plotting the graphs of tan theta, include error bars for 1 by r. So remember, error bars may be horizontal or vertical. Since 1 bar is on the x-axis, the error bars are gonna be horizontal. Okay, so the first one has an error bar of 4, 4, 3, 2, 2, 1, 1. Okay, so from 83, 83 plus 4 is 87, right? 4, 5, 6, 7, 87. 1, 2, 3, 4, like this. So you just have to join these points like this. Then 3, 63 plus 3 is 1 to 66, 1 to 60, like this. Next, 2 and 2, 1, 2, 1, 2, 1, 2, 1, 2. Now 1 and 1, from 27 to 28. Here we go. Ready? These are our error bars. I'm going to tell you the purpose of them soon. Now we are tasked to draw the line of best fit and a worst acceptable line on the graph, and we are supposed to label them. So let's go for it. It's a bit tough for me to draw. I'm going to manage. Okay, so this is fine. Why? It passes through all my points, but it passes above this one. So I'm going to try to make it pass below one of the other ones. Wait, let's see. Like this is not a line of best fit because it's not even. But wait, I'm going to show you the best line. This is probably the best. It passes below the first point and above the first and third, fourth, fifth point. So this is pretty good. This is a pretty good line. So make sure your line does not pass the axis. Like I had no choice or I couldn't draw the line. Make sure it doesn't pass. like this. Erase it if it does. Now to draw the worst acceptable line, you have two options. You can either opt for the upper bound of the highest point and the lower bound of the least point, or you could go for the lower bound of the highest point and the upper bound of the least point. Okay, so let's go for the first option. I'm just gonna join those points here. Okay, so I need to make sure it passes through this. On the other hand, it needs to pass through the lower bound of the first point here. So this is my worst acceptable line. Also, one more thing, you guys need to label these. So this is your, it should be done within the axis, by the way. This is your line of best fit. There's one mark for labeling, and this one over here, worst acceptable line. Okay, so why was this drawn though? Mainly we want to find out the uncertainty in gradient. Okay, so let's pick two proper points now to find out the gradient. Two pairs of points. So you can use points from the table if your graph passes through them, but it's better if you don't. But you can use them, it's totally fine. And make sure triangle is big enough, right? So I'm gonna go for this one. Do not write the coordinates down on the graph, okay? Don't make that mistake. And here, what about this? This looks perfect. This is our triangle. So I'm gonna find out the gradient of the base fit line first. So what's the point over here? It's at 70, 5.1, 5.2. It's between 5.1 and 5.2. It's like 5.17 or 18 maybe, 5.18. Okay. Okay, it's 5.18. So this is the gradient of the base fit line. 5.18 divided by 70 minus, what about this one? The blue one, right? So the blue one is at 25, 6, 7, 8, 28. 28 and 2. 28 and 2. 28 and 2. But hear me out. In the x-axis, we have it multiplied with 10 power minus 3. So make sure you don't miss these out, right? What are you getting? 5.18 minus 2 divided by 70 minus 28 into 10 to the power minus 3. I'm getting a value of 75.7. 1428571. There are no accuracy marks for this, by the way. No accuracy marks. Now what about the m of the worst acceptable line? Let's go for that. It's gonna be at 5, 70 and 5. 5, 70. And what about this point over here? It is at 25, 26, 27. It's at 27 and 2. 27 and 2. Minus 27 and 2. This into 10 power minus 3. 5 minus 2. 70 minus 27 into 10 to the power minus 3, which is 69.76744,186. Okay, now we want to find the uncertainty of the gradient. So just choose the bigger one minus the lower one. So m best fit minus m worst acceptable. That's 75.71714 minus 69.767. Okay, 75.71428,571 minus answer. We're getting 5.947. So remember, in AS, uncertainty could only take one salient figure. It's not like that in A2 in paper 5. It can take more than one SF. So we can just go for this. 75.7 plus minus 5 works actually. Plus minus 75.7 plus minus 5.9, this works. This is actually fine. Or you could also go for 75.71. Okay, this also works. 75.71 plus minus 5.95. This will actually give you a more accurate answer later on. Okay, so let's move ahead. The student measured the frequency of AC power supply twice. The student's values were 101 and 97. Determine the average frequency. Okay, average frequency equals to 101 plus 97 by 2. 101 plus 97 by 2. That's 99 hertz. 99 hertz. Okay. Using answers to A, C, 3, and D, determine the value of C. Oh, by the way, we need to include the absolute uncertainty in the value of F. So how does it work for averages? What's the logic? So when you multiply or divide, you need to use fractional uncertainties. When you add or subtract, okay, when you add or subtract, you just need to add the uncertainties. So was there any data given for frequency? Basically, uncertainty is the least division of your instrument. Okay, so since frequency depends on time, what's the shortest distance over here? One box, right? How are they actually finding this out? Mm, this is what they did. Like in case of average, it's how it's done. The uncertainty is actually the difference between the values, 101 minus 97 by 2. Okay, so if you're not given information, just go for this. So that's actually 101 minus 97 is 4 by 2, which is 2. So that is why the uncertainty is plus minus 2. Now using answers to A, C, 3, and D, determine the value of C, include an appropriate unit. We know that the gradient was 1 by 2 pi fc. 1 by 2 pi fc. Grad equals to 1 by 2 pi fc. So the value of the gradient was 75.714. 75.714 is equal to the answer of A. That was the expression. C3, that's actually our gradient rate. And this one, we can use the average value 1 divided by 2 pi into 99 into capital C. What are we getting? 1 by 2 pi into 99 into 75.714. I'm getting a value of 2.12 into 10 power minus 5. Okay. So we need an appropriate unit. C is capacitance basically. C is capacitance. So we know that capacitance has a unit of farads. Okay. So it's 2.12 into 10 power minus 5 farads. There are no accuracy marks for these, but they should be expecting an answer. So in the mark scheme it's 22 microfarads. So if you do convert this 2.12 into 10 power minus 5 from farads to microfarads into 10 power 6, we're actually getting this value. I'm getting a value of 21 microfarad, which is pretty close to 22. Okay, so it's fine. There are no accuracy marks, but this is what the expectation should be like. Now, determine the percentage uncertainty in C. What does C depend on? C depends on gradient, 2 pi, and frequency. But 2 pi is a constant, so it's just like this. Del C by C into 100% is actually equal to del gradient by gradient plus del frequency by frequency into 100%. That's it. So what was del gradient actually? 5.95, right? 5.95 divided by 75.71. plus 2 by 99, right, into 100%. Just do this. I'm getting a value of 9.88%, or 9.9% if you want, 9.8%. That's it. Now the experiment is repeated using the same power supply and capacitor. Determine the resistance of R that would give a phase difference of 40. For this, we need to use our whole relationship, right? Which is tan theta equals to 1 by 2 pi fc into 1 by R. Tan theta is equal to 1 by 2 pi fc into 1 by R. So we need to find out the resistance. Okay, so if you make resistance the subject, R is equal to 1 divided by 2 pi fc, right, into 1 by tan theta, or R is actually equal to 1 by 2 pi fc is the gradient, right, which is 75.71 into 1 by tan 40. Let's go for this. To 75.71. I'm getting a value of 90.23. Okay, this is our value. Now we need to find out the absolute uncertainty. How? So del R by R, what does it depend on? It basically depends on the gradient and theta. Depends on gradient and theta. Theta had no uncertainty, right? Theta had no uncertainty. Clearly. So it only depends on gradient. You could say that del m by m into, yeah, that's it. It only depends on the gradient. Or you could break it down into f and c. That's your choice. You would get the same answer. Or you can just go for gradient because it only depends on gradient, right? This value of R. That's why I can opt for this. So actually del R divided by 90.23 is equal to 5.95, right? 5.95 divided by 75.71. So to find out percentage uncertainties, just remember you need to backtrack and see what your value actually depends on. That's how you go forwards. Okay, into 5.95 divided by 75.71, I'm getting a value of del R is equal to 7.09. So what is our final answer gonna be? It's 90 plus minus 7. This is it for this paper. If you have any other questions, you can ask me. Okay, also make sure to subscribe to the channel, and I'm gonna link the Feb March paper 4 variant up top over here. Okay, if you need that. I'm also gonna be doing the specimen paper soon for 2022. And if you have any other requests, just let me know. I'm going to do chemistry as well later. Okay, see you guys.